everyone. Today we are going to learn 8.5 constant coefficient equations with piecewise continuous forcing functions. A long title, right? So we're gonna do only two problems here. Okay, so we added here from the equation and unit step function. Can you see that? Right hand side, right? Okay, now, and we add initial value problems here. And then solve for y of s. Yeah, we had the experience, right? Okay, so only difference with the previous example, we have a step functions, right? Okay, so let us do that. The first of all, from the original equation, let me copy here. Okay, then we take the Laplace transform every term, both sides, right? So let us do that. Oops, I wanna make this one. It's okay. All right. Okay, now let us do this one by one, right? So we get Laplace of y second prime plus Laplace of, let's take out the 16 constant, right? So Laplace of y equal to Laplace of, all right, so we have a term by term, right? So let us do that. 2t minus 4. Okay, how about I want to take out the constant 2, right? So let's do that. 2 Laplace t minus 4 use of 4 OT and do again. -2 Laplace of t minus 7 use of 7 over t, right? Sorry, no space. Yeah. Okay, so let's working on this one. All right, so Laplace of y second prime. So we knew that that will be s square y of s minus s y over 0 minus y prime over 0, right? And then I will keep continue plus 16. And this will be y over s, right? So y over s equal to 2. Okay, so let's take a look. Laplace of step function, this one, right? So what is the c in the case? C equal to 4, then we have the form, right? Yeah. C equal to 4. And then we can express as e to the negative c, so negative 4s, right? And then we will have over s squared, right? Because we are looking at the t, and then look, let me find out here. So this one, right? So we did this one before, t to the n power. So t will be t in the case n equal to 1. So 1 over, that will be 1 over s to the 1 plus 1, which is 1 over s squared, right? Yeah, we did this one in the last section, right? So over s squared, right? Yeah. So t minus 4, use of 4 over t, they are matching, right? So we are using 4 here, right? And then we are using t, and then we use s squared in there. Make sense? We did that last time, right? Okay, so here as well, we have a negative 2 as a constant. So c equal to, in that case, 7. C equal to 7. So we will have minus 2 e to the negative 7 s over s squared. Yeah, make sense? Okay, now, initial value problem. So y over 0 equal to 0, y prime over 0 also 0, right? So this will be 0. This is 0, right? Okay, so there will be s squared y over s plus 16 y over s equal to, we have same denominator, s squared, then 2e to the negative 4s minus 2e to the negative 7s. Can you see? Okay, good. All right, now we want to solve for y over s, right? Solve for. Okay, then the left side we have y over s equal, times s squared plus 16. And right side as it is. So copy. All right. Okay. Now, let me see. Okay, then solve for y over s. That's the question, right? So we divide by s squared plus 16, both sides. So we will have y over s equal to s squared plus 6. No, 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 no. So that fraction over s squared plus 16. I have with this one, right? Paste again. Then over s squared plus 16, right? Yeah. This is the one. Okay. Let us just stop here. We don't want to go more further. It's just like a warm up. But then second question, let us make equation. Yeah. Uh, all right. Okay, so second question we have, use the Laplace transform to solve initial value problem. So we have that form, piecewise function, right? Okay, then with initial y of 0 equal to 1, y prime of 0 equal to 0. Yeah. Okay, then we apply this formula. Yeah. So the first one is f sub 0 of t, and the second piecewise function will be f sub 1 of t. Okay, now let's make this form, all right? And then this will be t sub 1. Let us do that. So f of t equal to f naught, which is 3, plus u of t minus t sub 1, which is 4, and f sub 1 over t, which is 2t minus 5, minus f sub 0, which is 3, right? Okay, now f over t. So f over t, this is we consider f over t. So that will be y second prime plus y equal to 3. Okay, now we can express this one as u sub 4 over t, right? Okay, now we simplify inside. We have 2t minus 8. Yeah. All right. Look, 2 is a common factor, so we 2 out. Then we get t minus 4. Yeah. So let's make that y second prime plus y equal to 3. Use of 4t. And then 2 out, t minus 4. Yeah. Okay. We take the Laplace transform both sides. So there will be y second prime plus y equal to, copy. All right. Then let's make a 2 is here, so which is 6, right? Um, no, we keep that. All right. So let's make Laplace transform each term. Yeah. Okay, then, oh no, hold on 1 second. I made a mistake. Yeah, that's why. Yeah. Okay, good thing I didn't multiply. We have a plus there. I made a mistake. Plus. Yeah, should be plus. That's why I cannot make a multiplication there, right? All right. Now, Laplace of y second prime plus Laplace of y. So Laplace of y means y over s, right? And then we have Laplace of 3. And then other term has Laplace of 2. We writing constant in front, use of 4 over t minus 4, right? Okay, so what is the Laplace of y prime? So there will be s squared y over s minus s y over 0 minus y prime over 0, and that will be plus y over s equal to, okay, so let's make a pause. All right. Initial y over 0 equal to 1, y prime over 0 equal to 0, right? So this will be 0. Okay, then this is 1. So s squared y over s minus s times 1 plus y over s. Yeah. Okay, that is the left side. Right side, Laplace of 3, right? So I wrote down, I brought the form, Laplace form here, right? Transform. So if we have 1, then we have 1 over s, right? So if we have a 3, that will be 3 over s. Make sense? Okay, so we have that 3 over s. Okay, now I want to make it nicely. Note, yeah. This is f of t, right? This is f of s. Laplace transform. So there will be 3 then equal to 3 over s. Okay, what about this one? So we have Laplace of 2 unit step function, right? So they are match. So c equal to 4. So we had this one, right? So let me just write down, right? So we had experience we had the t, which is s squared, right? So we have c equal to 4. So plus 2 e to the negative 4s over s squared, right? S squared from the t, right? So t to the n power, n equal to 1. Yeah, we did it earlier. Okay, now, uh, equal to, let me just copy. All right, then, uh, we need to start for y, right? Now, start for y over s. Sorry, not the y. Okay, then we add s both sides. So that will be y over s squared plus 1, right? Then there will be 3, everything. Copy, paste. And then plus s, yeah. Okay, now we divide by s squared plus 1 both sides, right? So there will be s squared plus 1 over s squared plus 1, right? Okay, so then y over s equal to this one plus s. Then 1 over s squared plus 1 every term, right? So that will be s squared plus 1, s squared plus 1, and over s squared plus 1, right? Okay, now, this question, we want to find the equation, the function, all right? Eventually. So then we have to make a partial fraction decomposition like what we did previous section, right? Okay, let's do that. Uh, Let me do. Okay, so for the first term, right? 3 over s squared plus 1. We do partial fraction decomposition. Why? Because we're gonna take the inverse of Laplace, then we can find that function equation. All right? Okay, so we have a over equal to a over s plus b, look, s squared plus 1, right? So we have to have a one less degree, right? So we will have a bs plus c. Yeah, that's the form. Okay, then make a common denominator. So there will be s squared plus 1. Then we have s squared plus 1 plus bs plus c times s. Yeah, that's the first term. Okay, then we distribute. I want to make this way so that we can save the space. Yeah, so there will be s squared plus 1, as squared plus a plus bs squared plus cs. Yeah. Okay, now we set up this one equal to that, and then everything is equal sign, so we have a constant with a constant term. Yeah, so that means 3 equal to a, constant with a constant, right? All right, then we have a plus b s squared, which is 0, right? So, but then that means a plus b equal to 0. We have a equal to we have a equal to 3. Then b equal to -3, right? And then cs, we don't have s term, so cs equal to 0. That means c is equal to 0, right? Because there's no s term. Yeah. Okay, so then we can have that the form. So a again, right? So there will be a, let me copy, yeah. I just want to copy this one. Copy, paste. So we will get a 3 over s, b -3s, c plus 0. Yeah, we don't have to write down 0 over s squared plus 1. Yeah. Okay, that is the for first term. Okay, second term. This one, right? All right. Copy. For second term. Partial decomposition, right? Okay, now we have s squared, right? And s squared plus 1. Okay, but then we will have before s squared. What is before s squared? Like s, what we had earlier, right? Okay, so we will make the composite like something s, a, so something s means a over s plus s squared, and then s squared plus 1. Make sense? Okay, now let me write down for you. So it will be a over s. That's how we decompose. Yeah. And plus s squared, then plus 1. So we have to make one less. So vs plus c like earlier. And plus we have uh, s squared plus 1. So one less. Let us do this one first. We have to do s squared first. Then we are using v. Yeah, we don't use bs. Yeah, we're using v. And then cs plus d. Make sense? Okay, then there will be common denominator. So s squared, common denominator will be s squared, right? And then s squared plus 1. Now we understand why we have to make s, right? Yeah. So the composite is s. Even though we make a common denominator, we get s squared and s squared plus 1, which is the same as here, right? Okay, good. Now we have a now times s, then s squared plus 1, right? b plus b, then we need s squared plus 1, and plus we have cs plus d, then what we need? S squared, right? Okay, now we have s squared plus 1. Distribute, we have as to the third power plus as plus bs squared plus b plus cs to the third power plus ds squared, right? Okay, now, oh, this is a function and there is constant. So look, which one is constant? B is constant, right? So we look 2 equal to V that, right? V is only the constant there, right? Okay, now for s to the third power. So we have a plus c, s to the third power equal to 0. How about v? S to the second power. V plus d, s to the second power equal to 0. So that means, okay, let me move this one together. Almost done. Okay, now we set the b equal to 2, then d will be negative 2, right? So negative 2, b equal to b plus d equal to 0. 2 plus d equal to 0. So d equal to -2. Yeah. What is missing? So A plus C is missing, right? So we don't have any information, right? So only B and D, right? And then S to the third power equal to 0, right? So we can just say that A equal to 0 and C equal to 0. Since there is no S to the third power provide. Yeah. Okay, now let's do this one. So we have this one. Oh, do again. We have this format. Copy that. Okay, so there will be A, which is 0. Oh, B, which is positive 2, S square. Yeah. So we didn't have S earlier, right? Yeah. Okay. And plus C. Oh, C is 0. And D is -2 over S squared plus 1, right? Okay, let's arrange it one more time. So 2 over S squared minus 2 over S squared plus 1, right? Okay, so all together then, uh, look from the first term, we have a partial decomposition, and then we get this one, right? And then second one, we get this one. And third one, can you see that? We have only S squared plus 1. Yeah, it's already simplest form, so we don't need a partial decomposition, all right? Because in that case, we have uh, S times S squared plus 1. S squared plus 1, right? That's why we had to have partial decomposition. Make sense to you? Okay. So first and second, let me write down. So copy. So we have and that, right? Plus. Okay. Wait a minute. Uh, Therefore, only 2. We are using only constant 2. Yeah, we will use only 2 for the constant. Look, we did not use this one, right? Okay, this is a special. So we did not use that. We bring this one into here. So that will be e to the -4s of that for the second term, right? Okay, third term, we have s over s squared plus 1, right? Okay. Plus s over s squared plus 1. Okay, now look, we can combining, right? So what do you get? So 3s s negative 2s. Yeah, so there will be negative 2s. So there will be 3 over s minus 2s over s squared plus 1 plus e to the negative 4s 2 over s squared minus 2 over s squared plus 1. Okay? Okay. Now we need to take the Laplace inverse of Laplace form. Yeah? Okay, so let us do that. So all together, we take the inverse of Laplace, everything. And then let's take a look. This is a common factor 2, so we take out the 2, right? Yeah. So inverse of Laplace. So that will be 3 over s minus 2s over s squared plus 1 plus, okay, so 2 e to the negative 4s 1 over s squared minus 1 over s squared plus 1. Yeah. Okay. Look. Let us do that left side first. We had this one earlier, right? So if we had 1, then we take the Laplace, then 1 over s. Yeah. So we had 3, then it will be 3 over s. We did that earlier, right? But then this is the inverse. If we have a 3 over s, then we get 3. Yeah. Make sense? Okay, now, what about this one? So we take out the constant, and then s over s squared plus 1. So omega in the case is 1, right? Look, cosine omega t. Can you see? Yeah. So this is omega equal to 1. Yeah. All right. What about the here, right? So we keep the 2. Okay, so look, this is, we had that earlier, it's t. Yeah, and then this one will be omega equal to 1 as well, right? So this one omega equal to 1, and then this is think t, right? So there will be t to the n power. Yeah, let me bring down for you. So you know what I'm talking about, this one. Yeah. Copy. Paste. Yeah. Okay. One more page. So then there will be sine t, right? So there will be sine t. Okay, now look. We know this is a 3. We know this is a cosine t. And we know this is sine t. But then we have e to the negative 4s. Remember, if we have e to the negative 4st, right? Then this one will be what is called? We have a step unit function, right? So there will be ut to the t minus 4 because c equal to 4, right? And t minus 4. Or we can express as u to the 4 over t and t minus 4, right? Make sense? Okay, so in that case, we're not using just the t. We are using t minus 4. Make sense to you? Okay, so let me write down. We have, let me write down this one first. Yeah, so think use of 4 over t minus 4 is same as u of t minus 4, right? This is same as e to the negative 4s. Oh, and then 1 over s squared, right? Yeah. Okay, so this is from, we might think about what's the inverse of Laplace, f of s equal to f of t, right? We knew that, right? Then there will be inverse of Laplace e to the negative cs. We're using c notation, right? So f of s equal to u sub c. I think they're using a, but it's okay. Over t f of t minus c. Yeah. So this is similar with this one. Okay, now, so all together, so we are going to use that. One more time. This is a copy. Now, equal to, right? So 3 for the first term, yeah? Negative 2 cosine t for the second term, plus 2, and then u sub for t and t minus 4 for the this one. Yeah, make sense? And I want to make a bracket and second term. So this will be sine t minus 4. Make sense to you? So we done for this section, and then there is a Laplace transforms table here. Okay, thank you for watching. Bye.